So we're going to look at piecewise functions. And a piecewise function is basically a larger function that's made up of smaller functions that are applicable only over certain ranges. So the way we're going to list this is we're going to do f of x is equal to, and it's going to be equal to a number of different smaller functions. So we're going to kind of go through these one by one. The first one is we're going to look at this one right here. And where it starts, it looks like it starts at x equals 2 and y equals -2, and then it continues horizontally indefinitely. So that means that we have a value of y equals -2 because it's a horizontal line. So I'm going to put -2. And this is true when x is greater than +2, because that's where it starts, and then it keeps going. We're not going to make it equal to or greater than 2 because we have an open circle, which means it's not going to be quite at 2, but just slightly above it. So we're not going to do that. Now, the other one that we're going to start with is over here. And this one, if you take a look, is -1 for x and up 2 for y. And it's also a horizontal line, so we're going to say y equals +2. And so we're going to do the same thing. It equals 2, and then it's when x is less than, because it's going toward the negative direction, -1, because that's where it started. And in this case, notice we have a closed circle, so we are going to make it equal to as well. So that's going to be kind of our defining piece of information, is if it's open or closed. And then the one in the middle is going to take us a little bit more effort. It's right here. And the easiest way, because it's not as easy as a horizontal line, is I'm going to redraw it over here just so that we can kind of see it a little bit easier. So we're going to make some lines. Okay, so it starts right here, right? And that point is 2, 0. And then the next point is right here, which is 1, 1. The next one is at 0, 2. And the final point is right here, which is going to be -1, 3. Now, there we go, we have this line. And so what we need to do is we need to find the equation of this line. And as you recall, equations of a line are y equals mx plus b. So we are going to find m. We're going to choose 2 of our points. I'm going to choose these first 2. And so we're going to do y2 minus y1 over x2 minus x1. M is going to be our x and y values. So we're going to do 0 minus 1 over 2 minus 1. And so what that gets us is -1 on top and +1 on the bottom. So our slope is -1. And then we're going to find our b. And the way we're going to do that is we're going to choose a point and just plug it in. So I'm just going to choose a different one for the sake of an example. And y is 2. Our m we just solved for was -1. The x for this point we just chose is 0. And then we have b. So 2 equals -1 times 0 is 0 plus b. So that means that 2 equals b, or for ease of reading, b equals 2. So our final equation for this section is going to be negative, and you can write -1x if you're comfortable with that, or you can just write -x plus 2, which is our b. All right, so we know what our equation is, so -x plus 2, and to figure out where this is going to be applicable, we need to look at the starting and ending point. So the starting point is right there, which is 2, 0, and it has a closed circle. And the ending point is -1, 3, and it has an open circle. So that tells us that the range we're going to do is -1 is less than, with an open circle, x, which is going to be within the range of 2. And notice at the 2, we have a closed circle, so we're going to put a line there. So that tells us that x is within the range of -1 and +2. And that is how you are going to solve this. So our final answer for this specific one is going to be f of x equals -2 when x is greater than 2, -x plus 2 when x is between -1 and +2 and equal to +2, and f of x is equal to 2 when x is less than or equal to -1. And that is how you are going to solve this problem. We are going to work on a piecewise function that uses a word problem. So let's first read through this word problem. A taxi company charges $2 for the first mile or part of a mile, and 20 cents of each succeeding tenth of a mile or part. And then we want to express the cost, C, in dollars as a piecewise function of the distance x traveled in miles for the range of 0 to 2. Okay, so first thing I'm going to write C equal to, and then put squiggly bracket, so we can put that there. And then I'm going to put a line here so we can really look at what happens between 0 and 2. So I'm going to put 0 here, 1 there, 2 there. If we notice, it's less than, not less than or equal to, so I'm going to leave an open circle so I remember. And on the other side, I have less than or equal to, so I'm going to put a closed circle. Now, C is already told to be in dollars, so I'm not going to use the dollar sign going forward because it's already implied. And we are going to first look at between 0 and 1, which says that it charges $2 for the first mile or part of a mile, which means that any distance between 0 and 1 is going to cost $2. So we know that C is going to be $2 for this section, and that's when x is greater than 0, right? We're still, because we had a less than and not a less than equal, we're not going to put the equal sign. And on the other side, we are going all the way up to where it hits 1, so we're going to put an equal sign, 1. So the first part of our piecewise function is that C equals 2 if you drive between 0 miles up to 1 mile. Now, the other part we want to figure out, and on this side, what we have is we have 20 cents, and 20 cents is, we need to rewrite into dollars, and we can do that by saying that there are 100 cents in a dollar, so we can divide both sides, and that gets us $0.2. So an example that we can look at is that if we look at 1/10 of a mile more, that's going to be kind of right here. That's going to be 1.1 miles. And this distance is going to be the $2 to get to the 1 mile plus the 20 cents to get the extra 0.1 mile. And so that gets us 2.2. Let's do one more so we can just kind of compare. So if we go to 1.2, what we see is, we'll use purple, is that we are still going to the 1 mile mark, which is $2, and then there are 2 times of these 0.1 sections, and each of those cost 20 cents. So that's going to be 2.4. So what we're going to do is we're going to find an equation that helps us identify between 1 and 2. And what we're going to get is every single time there's a 2 in front, so I'm going to put a 2 in front, and then we add a certain amount. So notice in this first one, it was 0.2 because technically it was times one of those distances, right? So the way we are going to do that, and because it's 0.1, we have a little bit of a math fun that we have to kind of figure out. So I'm actually going to rewrite it real quick down here. So 2 plus the 20 cents times the distance, which is 1.1, minus our mileage, that first mile, right? Because we've already accounted for it. But because we have to deal with tenths, we're going to take this whole thing and we're going to divide it by a tenth. So what we get, if we simplify this, is we get 2 plus 0.2 times 0.1 all over 0.1. And in this case, the 0.1 and 0.1 cancel, which is really nice. And so we get 2 plus 0.2, which we definitely saw when we looked at 1.1. So we get 2.2. All right, so the way we're going to write this out is we're going to do 2 plus 0.2 times our distance, x, minus that first mile, all over 0.1 because of the tenth of a mile math that we have to do. And this is going to apply between 1 and 2. And we're not going to put an equal sign on the 1 because that 1 is already accounted for in that first part of our equation. And so that is how we're going to get our final answer for this.